God, oh, I didn't do my lower third. I need
Oh,
to do my,
good idea.
need to do my lower third.
I've been doing it like halfway through the show for the past two or three shows.
World famous clothing designer Twitter tag. Let's do a whole show
Uh,
with all my tweets, people celebrating me, my
right,
accomplishments.
right. Oh, and now we gotta tweet that shit out here. All this pre-recording stuff.
Oh, that's the YouTube one?
Yeah.
Okay, and then I think if I go in there, doesn't it say join the Hangout? Don't I get a link for that? We have one viewer, though, and that's me.
Yes, you would count as a viewer if you come to the page.
One watching now. That's right. I am watching.
You're watching yourself record? Are you being a voyeur against yourself?
All right. Come on. And retweet.
Oh, yeah. Guess I can retweet that.
All right. We ready?
Yes, we are. We doing the countdown?
Yeah. All right. 3, 2, 1, go. Hello, and welcome to the Static Void Podcast. I'm Jess Chadwick,
I'm Todd Snyder.
And I'm Chris Gomez.
and we are your hosts. We're recording this on the evening of June 8th, 2016, and in this episode, we're going to be talking about modular component-based web development. Now, this comes hot on the heels of our previous show, in which we debated the suitability of the web browser as a development platform in the first place. So in this show, we're just going to kind of accept our current browser environment and our platform as it is, and just kind of figure out what are our favorite approaches that we use to create maintainable web applications in that environment. So, Todd, I know you and I, we had a lot of debate on the last episode, and you had a couple of complaints, memory management and things like that. My biggest issues are really with just kind of the I guess the soup of the tag soup, I think you called it in the last episode. So the tag soup of just kind of throwing a bunch of stuff on a page, and in the JavaScript just kind of referencing global variables and registering everything globally and everything. And so the approach that I've really advocated over the past couple of years certainly is more of a modular approach. And so over the past couple of years for me, that's really been a modular approach in Angular. But I'm just wondering, like, what have you two been up to, Chris and Todd? What have you been up to in terms of making maintainable web applications and trying to kind of put some componentization into it and making modular stuff that you can maintain?
Well, for me, the number one way you make maintainable code is threaten your developers' fingers that they won't make the same mistakes more than once.
Right.
I mean, pretty much I've been living in the Angular world pretty heavy the last 2 or 3 years, building some fairly large type Angular applications that had to take advantage of the different components and things you can have in Angular, whether it be services or directives or whatever.
Mm-hmm.
Probably the biggest challenge I have, though, is, and you mentioned the JavaScript soup and things, is still intermixing certain things like jQuery UI controls or like something like a jQuery mobile, intermixing it with these other frameworks. And
Right.
sometimes they don't always um, work, or they add an additional layer of complexity. And that's one of the things I think when you start thinking about the patterns of modularity or components, you're really trying to take complex applications and put them into a small workable unit. A, because it's just easier to code that way. It's easier
Yeah.
to have other developers working on different things. You have one guy working on the search grid, and another guy working on some other UI component thing, user profile or something. Um, but it also allows you to, if you hit a certain like breaking point, where you just, hey, this isn't going to work for me. I can't use this directive and this jQuery UI control together because I modularize it. At some point, I can say, okay, let's go in and we'll do a pure directive, or we'll look at a different component or something else to do that. And if you hadn't done that, if your applications were totally tied together, it's a lot harder to peel something off without
Mm-hmm.
breaking the rest,
Mm-hmm.
having
Mm-hmm.
or leaving behind remnants of what you did. So I think
Yeah.
that to me is the biggest idea of componentization. I know we're going to focus on the UI, but it's when we talk about components in general, components mean just taking something and breaking it down into the smallest workable unit that makes sense.
Yeah, right. I like to think of
Well, I
it as
mean,
like an electronics breadboard, right, where you just kind of literally plug in what the hell is the word
you
for
want
it?
to plug in like an IC, right?
Yeah, right. You plug in an IC or even something simpler than that,
Maybe a
right?
sensor or some
Yeah,
connector.
exactly. And that sensor was just, it was created in isolation and it was meant to just be plugged in. And if you rip it out, that might kind of break the circuit, but you can replace it with something else. And the system as a whole is not affected. Maybe that one part or that one piece of it is, but
Yeah, well, I mean, abstraction in general is like fundamental, but bringing it to web page views is really hard. And so one of the things I noticed that both of you immediately went for, even though we're not necessarily talking about any specific framework, is said, well, hey, and we're trying to combine maybe some jQuery UI plugins with Angular. So we've already jumped away from just the base web.
yeah.
And it's, I think probably we can all agree that the base web didn't give us the tools to abstract, right? I mean,
Yeah.
HTML by itself, without specs that are coming down the pike, right? Let's not worry about those.
Yeah.
Doesn't, I mean, its unit of abstraction is the page, and that's it.
It's the DOM. So I've been having this conversation with a lot of people lately, and the folks that I've been having the conversation with were concerned about like multiple teams, many different teams, kind of developing their own components in relative isolation and kind of using the approaches that they want, and then coming together, finding this like kind of core standard API that they can use to kind of bring those components together. Even whether it's like a React component and an Angular component, no matter what the internal implementation of that component is, creating them, bringing them together, which you were referring to specs that are coming down the pike, which I'm assuming you're referring to the web components spec, which I've effectively dismissed at this point, right?
Yeah,
So
right.
I've,
Because it may not happen, right?
well, right. So IE 11, the IE blog, the IE folks, they already said like literally, like technically speaking, we cannot, will not ever implement the shadow DOM in IE. That was kind of one of the drivers for just kind of throwing away that code base and starting over again, meaning
Yeah,
Edge,
yeah.
right? So like they've already said like don't ever expect it in IE 11, because it's just a significant undertaking. It's a significant undertaking in any browser, but certainly with that code base. And even the other browsers that have tried to implement it, they're all of their implementations are to various degrees of actually working, right? They have their various degrees of functionality, and then their implementations are incredibly compatible. So as far as I'm concerned, it's back to the drawing board, and the spec, as we know it, is effectively dead. It either needs to be significantly reworked or just recreated under the same name. But the idea, the concept, is still incredibly sound, and it needs to happen. It absolutely has to happen. So the idea of a web component, meaning you take something, some kind of behavior, logic, and interaction patterns and everything, some implementation, and you wrap it in this standard abstraction layer, i.e. the DOM, which is the universal API of the browser, the DOM and the JavaScript API, the core JavaScript APIs, and that's how you interact with it, that needs to happen, right? And then everything you do within that component is completely isolated. So including up to and including all your CSS rules and everything, right?
So
You're not letting anything leak out.
what's an example? Is a login widget an example?
Yeah, right. What is a
Is that too
component?
small? Like you come to a website. I imagine we've all seen this. You come to a website, and in the upper right-hand corner, it's teasing you to log in. And because they're trying to keep it single-page application, they don't want to post back or anything. You'll go take your mouse up there, and down will drop a little login widget. You can log in right from there. That is that a component?
Yes, everything's a component.
Okay, so now
That's
let me ask this. What if, have you ever been to the site where that's one way to log in, but then you might actually click the login button and they say, okay, fine, you didn't want to use the little widget, so now let's present you with a page with a fatter, more prominent login dialog. It's
sure.
bigger fonts. Is that the same component?
It could literally be the same component. It's certainly the same functionality. And depending on whether or not you're taking like the MVC approach, it could be the same controller with a different view, right? Because it's still the same underlying logic. But I mean, going back to what you just said, I think that's at the crux of it. At least it is for me. When we're talking about modular component-based development, my motto, to the point where everybody I work with now is just rolling their eyes whenever I say it, but I say it all the time. Everything is a component, up to and including the application itself.
Right.
Everything is a component, and you need to think it that way, because as I've spoken with with various people over the past couple of years, you naturally hear things like, well, in the application, we'll use this pattern. At the application level, we'll take this approach, or we use this pattern, or create a whole API to use just at the application level. And then when we get down into the widget level, then we're going to do this other thing differently. And then in the middle, there's this like component or some other word, this feature or whatever you want to call it, right? And they like treat these things as different things. What I'm saying is, once you say everything is a component, and a component may have child components in it, and there's that strict hierarchy, everything becomes so much simpler, right? And you can approach that hierarchy and all of those rules, and I'm hoping we can kind of talk about this hierarchy and these rules. At least this is the way that I'm doing it. I'm not saying it's the only way to do it, but when you kind of approach it this way, everything becomes more simpler, because you can start talking more in kind of absolutes. And I know there are no absolutes in software development, but you can more say like, here's the way we're always going to do it, except for maybe this thing that happens here and there, right? But like, you really can say, for lack of any other, unless there's really truly an exceptional case, this is how we're going to do it pretty much every time. These are the rules we're going to follow. And it applies to the application as a whole or that login widget.
Well, what you're describing, though, is because it sounds like you're trying to free the team or the person that's working on each component to use the patterns or practice that works best for them, instead of trying to define it for the whole application and then having to make exceptions everywhere. Because logging people in is not the same activity as taking their order, but yet they both cause fundamental important side effects on the system. Logging someone in is you're identifying who they are. Do you trust that they're the person that they say they are? And more importantly, can they trust your site that you haven't screwed it up, and they're going to get to see someone else's account information? But then taking an order to go deliver some product, that's important too. You might be taking financial information down, credit card information. You got to protect it. And so if you make application-wide rules, well, you're probably going to have to make exceptions to do things where it sounds like what you're trying to drive at is let each of the components in the system solve the problem the best way. Like, would the login widget talk to a login service? I mean, it's totally not caring about the rest of what the app wants to do. Instead of having a master API that tries to do everything, you have these component APIs.
Yeah, right. Well, and I think that's kind of part of the definition of modular, right? Is that you have these individual modules that take care of one responsibility. So you have the login, you have various other things, and you may, in that login, it may have a far higher emphasis on things like security. But when we're talking about when I say universal rules or these kind of universal patterns and approaches, immediately we start to kind of break them down into different kind of subsections. So I have a differentiation between smart components and dumb components, and this isn't mine. I've found it on the web, right? So I've seen it called many different things. One of the more recent ones that I saw was a container component and a presentation component, right? But so no matter what way you want to say it, you've got this component, these two types of components. One of them is smart. One of them knows how to do things and orchestrate things. That's another way that I call it. Another way I refer to this container component is an orchestration component. It knows how to orchestrate a workflow, or it contains that business logic. And then you have the presentation component, which all it does is take the results of that logic or that orchestration and display it to the user, and then tell that orchestration layer that, hey, the user did this. Right. So a great example of that is like a list of stuff. You have a list of customers that you want to be able to go in and click on one and select it, or click the delete button in that list and delete that customer. If you split that up into two different things, you have the container or the orchestration component. That's the thing that's responsible for going and getting that list, getting the data, giving it to that presentation component. The presentation component displays it, shows it, accepts that click from the user, and then it doesn't do anything with that click. It doesn't go and make that delete call. It just tells the orchestration component through an event or whatever. It tells the orchestration component, hey, this happened. The user clicked on this. What do you want to do, right? And maybe the orchestration component doesn't do anything with that information. It just says, okay, right? I don't care about that at this point. Or maybe it goes and it makes that delete call and deletes it, and then goes and maybe updates the data again and gives it back and refreshes the list that that list component is showing.
I think you hit on one of the common use cases for component case development. Sometimes if you talked before about applications and things, where I've worked with a lot of components and modules is what the term they call composite applications, where you'd have like the scenario you're talking about there, where you have some list, right? List of orders, list of customers, whatever, and someone clicks on it, and then the rest of the application needs to now do something because something was selected, a customer was selected, right? Maybe you have you see a list of customers and you can see a list of all their orders, but until that list did something, the rest of the screen was empty or showed different data. And the idea here is if you don't use a component kind of concept, what you do is you have an event somewhere in JavaScript or whatever, you ascribe to that event, you get the data, then you go update the orders. And now you have that coupling. The list component or the list piece is tied to the orders, or orders is tied to it. It's very hard to break this apart.
It might even be in the click event, right?
That's what I meant. You have click events.
Yeah. I mean, people are writing the code that does the work
right in the click
event.
The
click event. Yeah.
Yeah. If you follow that composite type thinking component sort of patterns, because there's about 15 to 20 kind of patterns all related to this, from like observer type patterns. That's like we talked before about Angular. That's one of the reasons why things like Angular get used, because it's good to be able to observe things. If you have the customer selection widget, we'll call it, and then he just simply says, hey, a customer got selected, here's the customer that got selected, my work is done. Somewhere else in the application, something else is responding to it. It may be, like you said, just an application level thing, or maybe 3 or 4 other components that say, hey, customer got selected. That means I need to go get orders because I'm the order widget, or I need to go
or I show customer
chart
detail
or something. Huh?
Like maybe one little panel knows that if a customer has been selected, I have to show its details, address.
Yes. Yeah. But that component itself is self-contained. It knows how to go get its details. It's not relying on something else. And the idea here is when you sort of do these things, it becomes a lot easier to take those same components and put them on their other screens, or go a level higher of abstraction, and you start seeing common patterns between your application, right? I use search grid as a perfect example. I've worked in a lot of applications where we had 10 different search grids, but there was a commonality between them. Some list was displayed. When you selected on something, you navigated to another screen. There's some commonality, and by using a component kind of concept, we built it once, and then we didn't have that click event in 7 different places.
Well,
Say,
so
I already got it. Good.
there's also an alternative approach to that. When you're saying that you have multiple things, and Angular is a good example of this. Angular supports this very well, but even just generally speaking, the concept of mix-ins, where you can define this behavior that you can attach to pretty much anything, right? So we did this a lot in WPF and even in Silverlight. So you create this kind of list thing, a list of customers, list of search results, list of whatever, and then you kind of attach this behavior of print this list, right?
Mm-hmm.
Some kind of generic cross-cutting concern. It attaches to a generic concept of a list, but it's not like a base class or anything like that, right? So you're not using literally that same component and putting a list of search results into it and a list of customers into it. You're creating 2 different components, a customer list component and a search result list component, but then you're attaching that same behavior onto them.
Mm-hmm.
Is that kind of what you're talking about, or you're?
No, I mean, I wasn't specifically talking about that, but you are correct. By going down this same pattern, you can start identifying behaviors or common pieces that you can attach to different things. I use context menus. A lot of places we have to tap in a context menu. So we could create a context menu component, and then we simply say, hey, grid, here's your context menu. And the grid's like, great, okay, if there's a context menu, I right-click, show it. If there isn't one, I don't do anything. Right. But the grid itself isn't worried about any details. He just simply says, hey, I have this related thing to me, I make sure it displays. Yeah. Or whatever.
Well, what we're really describing is composition over inheritance, right? So
yes, well, I mean that's why it's called the composite pattern or composite frameworks.
So what about effort for developers? Because the easy path is to just start embedding logic.
Throw a bunch of JavaScript code in there and hope it works.
Yeah. Isn't the simple path to just build an HTML form, and I'm talking even if you're using a framework like Angular, the simple path in Angular 1 is, okay, awesome, I'm using Angular, I'm using a framework, so now let me build a form and then let me attach a controller to it, and then I'll just do what I need to do when the controller fires. And you're completely, you're not writing services, you're maybe not even using, I've heard that a lot of people like directives as the building block for components instead of, and the controllers are really kind of dumb. The controllers just simply say, all right, something's been clicked. I know. I immediately am going to invoke services with the data. I am not going to know what happens. I don't care. I don't know what happens next. I just know that I can pass along a piece of data from the model and go to it service that will update a customer or place an order.
Yeah. So it's funny that you're using terms that sound very generic, like service and controller. I guess directive is kind of borderline, but these are all really what you're referring to, or the way you're referring to them, are actually Angular implementations.
I'm specifically
things,
picking
right?
on it. Yeah, no, I'm picking on Angular because I'm just saying, I'm thinking about the developer they're trying to get something out of this, of like, well, what's the path of least resistance is for me to just do the work right here. So how am I going to transition away from that?
So I want to jump in here because I've seen this a lot, and what I always tell people is really, to me, what you were describing was the MVC pattern, right? And yes, when you start adopting a pattern or you start adopting a framework or composite type approach to doing things, the initial effort's harder, but what you're doing is you're baking in good design. Mm-hmm. So on the long term, the effort will be less and less because you won't keep reinventing code, or it's more maintainable. Now, by just putting a framework in or just using patterns, you're not guaranteed to get that. You still have to be very disciplined to do it right. But the patterns and frameworks, particularly ones that you pick good ones, they kind of push you towards something, right? Think of ASP and MVC, right? ASP and MVC simply says, you want a controller? It goes in this folder as a controller. Right. It's pushing you towards the patterns and things. Which
but then a lot of samples, the controller just creates the EF context right there and writes to the database right there, right? And
which is absolutely, and at least in my opinion, that's a bad thing. Because you should have something else that does that work.
It's not reusable if you do it that way. It's only it only works in that controller.
Joke with Jess, there's a reason the M comes first in model view controller. Yeah. The view and the controller don't matter. They're just there for the model.
Yeah.
The
Right.
model is the point thing.
And this is
Um,
what I'm kind of getting at is getting away from tutorial after tutorial that says welcome to whatever framework, and the work
whatever
is
platform.
done. I don't care what it is. We picked on MVC, ASP.NET MVC, and Angular now, but I mean, come on, let's go back to form load, right? In web forms.
Well, look, that's a hard problem, right? Tutorials are always, by definition, they are always concerned about teaching you the concepts, the fundamental concepts, and the API, the syntax of that framework, right?
Yeah.
That's all they're concerned with. And it kind of assumes that you are going to learn the right way of doing it, or at the very least, if you are at the tutorial level, that 100 level, you're not ready to learn kind of patterns and practices on top of this. You're just trying to struggle to learn what is the basic stuff I need to know just to start using this stuff, right? And so then you can kind of look around and either, go to podcasts like this one, or look at some of the design books that are out there, the common knowledge about design and design patterns and everything, and figure out for yourself how that fits in, or maybe go read some advanced blog posts or some Pluralsight course or something, right? But those, once you get to that point, you already know the syntax and the APIs and how to put everything together. But the tutorials are all about that lower stuff. But yeah, I mean, I'm agreeing with you. Like, it is absolutely absent. But what's the alternative, right?
Well, I think the alternative is we figure out how to get people to the next level, right? Like, and I'm not saying to change the tutorials. What I'm
So
saying
the
is,
end of the tutorial, you say, and then next step
right, because
is learn how to do it right.
maybe there are some things that should start to smell,
Yeah.
and one of them could be that if you do stuff logic, outcomes into what you're saying, Todd, is the non-essential piece, or the should be the dumb piece, the controller. Well, then the way that shows up in your source control history is the controller files being modified all the time. So that means probably not doing a single thing. So we're violating single responsibility. Changing for, it's every time the app needs to change, you got to go hit this one thing. So, like, is that a way to start noticing that, hey, maybe my design's telling me something's wrong because I'm seeing that particular blocks of code or files are changing all the time? If you could somehow visualize it.
Yeah, I mean, you're almost talking about why components matter. Why this we have this discussion. Because if you have the same group of code that keeps touching, to
then it's
me,
not
the
componentized.
code smell is maybe not necessarily a single responsibility. Well, it is in a way. It's maybe I have smaller components in there I need to deal with, right?
Right.
I shouldn't have one controller. I could have the whole concept of parent controller and child controllers, or I could have maybe there are different components in the screen or other pieces of the application that make sense to have that. We use logging as a good example, right? I think we all agree it makes sense to have something like a logging service or a logging component. We don't want to have to write log wherever, call a web service to log this in 4,000 places. I think we'd all agree that's a bad thing, right? And I think the problem is, Chris, you really hit it on something that's very important. It's kind of a little more off track for what we're talking about here is all these things make sense if you know them or have a good mentor to help you learn them, right? Well, in my experience, you can have all the tutorials you want, you can have all the videos you want, you can even read all the books you want. If you don't really know these things and know when they work and don't work, it's a lot harder to get started. And I think that's the problem. It's what you said. It's much easier just to start jamming things in there and get it to work, right?
Sure. Well, and I think in the absence of a mentor or even books or anything, I mean, you need to learn it somehow. But in the
Yeah.
absence of a mentor, literally doing a code review and saying, well, you should do this, this, and this, I think the more practical way that most people are going to learn is really just by doing it and failing, right?
Mm-hmm.
So I'm agreeing with you, but I think it sounds like a very pessimistic outlook of, well, if you don't have someone to sit there and tell you how to do it, then I'm not sure you're going to be able to ever do it right. I think you can do it right, but you're going to do it wrong a lot more. Right?
Even if you know what you're doing, you're going to do it wrong.
Yeah, yeah.
This is why I tell people refactoring is not a stage or it's not a thing. It's something you do all the time. Your code should constantly be evolving towards something and away from something. It's okay to change code. You can't be afraid to do it. And I think that's a problem we have in general as an industry.
Yeah.
Oh, this code, we can't change it. No, if you do have that componentization, if you're really thinking about those smaller pieces, if you want to change the grid, rip the grid out, put a different grid in.
Right.
Shouldn't that decision of why you did that shouldn't affect other things. You talked about in the beginning having other teams work on different pieces of the application. If they want to go find a great jQuery grid that does what you want, and you want to work with Angular, as long as their component will plug into you and it doesn't introduce any friction, you shouldn't care what they're doing. It's a contract, right? It's a contract between you and them on that pieces. I think all this stuff is harder in the web, particularly because of the way the DOM works, and also because we don't have true like interfaces and other things. We don't have these contracts at the code level. We kind of have to live in the confines of how JavaScript works as a dynamic environment.
All right, so I think you just said a bunch of stuff there, and I think you hit a lot of the topics I was looking to get out of this show. But let's nail it down, right? So in the web, so you mentioned contracts and interfaces, and I think you even mentioned inputs and things. So in my original example of the electronics breadboard, at the most basic level, you have an input and an output, right? You have inputs and outputs. You have current coming in one way, and then it's coming out the other way, and it does something in between, maybe. So that's one of the approaches that I like to take when I'm kind of breaking things down into components, is say, like, what are the inputs, what are the outputs? And again, this applies to whether I'm doing a UI component or even
what is the content?
We've talked about this several times, especially in reference to like functional programming and pure functions that don't have any side effects, right? They literally, for a given input, it always gives you a given output, right?
Predictability.
So what, kind of bringing it down to that basic level, what are these approaches that you guys practice in the web? Like when Todd, you just mentioned contract interface. What does that actually mean?
Yeah.
What is a real world implementation of that?
So it really depends on what you're trying to do. I've worked in a lot of dynamic type environments, so it's a little harder to do this. But if you don't have that dynamic nature, like you know what the fields are going to be on the screen and stuff, it's just creating a class, right? It says, okay, here's the form that what I'm going to take in the form, and here's the UI to it and stuff. Just thinking about those things as the smallest workable unit to me makes sense. I don't have an interface to work with, but just putting it down, this is what I expect. This is what I expect the form to have.
Well, but I'm talking more of a higher concept, at a conceptual level. Like, do you have any like rules or kind of design patterns or things that you follow at a higher level? Because I don't think creating a class is really one of those rules, right?
So,
like I threw out a couple of them already, right? So I have that strict, everything is a component, and you have this idea of a hierarchy of components where parents have children, and then the smart components and dumb components, right? Or container components, or orchestration components, and presentation components.
So
also inputs and outputs. So
thinking about
anything like that?
Yeah, thinking about that, I actually take a step back further. I think about when I look at an application, the first thing I think about is what are all the features? What is the user trying to do? And then you end up with, okay, what things are related to each other? Usually it's a screen, right? What are the things on the screen? And then I start breaking them apart logically, and then I start saying, well, that's one thing, and that's one thing. So from the beginning, I'm componentizing things.
It's crucial.
I'm not
just in one
to build them as
right?
components. When they come to implementation, it might be a different thing. But thinking about that, because then the first thing I think about is, what are all the pieces I need for this? All right, well, search, right? Well, I need some web service that's going to give me the data. I need a UI that probably has X, Y, and Z into it.
Right.
And then eventually I need...
This is across the whole application, right?
Yes.
I mean, this isn't just one page and taking that in isolation. This is across the whole application. So
but it's the
page 1 and page 10 have these two concepts on them.
But if you break them down, like start from the beginning to like search, then you start saying, well, what things can search? What things have this behavior? All right, well, there's a way to search for customers, a way to search for orders. Now you have commonality. I think what a lot of people make the mistake, at least this is my opinion, is they think, and I hate to use this word but I think it's true, they think too much like a coder and not enough like an engineer. You hit on something before about the component board. The reason why a lot of this stuff is used in other engineering practices, because there is no it's a physical thing, right? If you're the component you're going to plug into the electrical board, if it's not the right type, it's not going to work, or it's going to break the board, right? And that's a physical thing. In software, we seem to have this, like, I don't know how to describe it. Like, deep understanding that we can take things like that and apply it in software. I don't know what the problem is, but to me, that's just how I do it. I don't think about frameworks and components. I think about behaviors. What are the behaviors? And then from that, I drill that into, well, how's the best way to solve that? And for me, it's componentization.
Yeah.
Smallest unit. It's easier to test. It's easier to have different developers work on pieces. That's a big thing for me. I like to try to isolate developers from each other as much as possible.
Right.
I just
Right.
found
Well,
that having that.
I've seen a lot of developers go down that path too, fall down that hole of, well, this thing is really complex, so I'm just going to start at the beginning and just keep
code your
going.
way out of it.
I'm just going to code my way out of it. I'm
Right.
just going to start with this page, and I'm going to code this page, and I'm going to go to the next page, and I'm going to code that page, as opposed to what you just said, Todd, which is like, let's look at all of the functionality that's being requested and see, well, page 1 and 10, they each have the same basic needs, right? The same feature that's being represented in both places. And so, like, let's build that and build it in a certain way so that we can reuse it over here. Or, I'm totally agreeing with you, Todd, right? Or, like, we have this concept of search, and you may be searching for a customer or you may be searching for orders, but we have this common way of just kind of, even if you just call it a UX pattern, right, of displaying these things and interacting with these things, even though the data points shown and maybe even some of the actions that you take on them are completely different, it still will feel the same. Is there a component there too?
Yeah.
Right.
And for
Because
me,
when you're building the search component, not every search involves somebody typing random characters into a text box. It could be just clicking on the customer's name,
saying, "Give me all the orders."
which is, it implies that you're searching for that customer's orders. It's just a more direct query than I'm just going to type, I'll just make something up. I'm going to type Darth Vader toys, and that now goes across the spectrum of customers, orders, regions,
right.
and who the heck has ordered things that are like that.
Mm-hmm.
I think you hit on the thing is by looking at that higher level abstraction, you start to see these patterns. You see, like, hey, we're not doing a free text search. We're doing where you select something and then you see the last 20 orders or the last 20 of everything.
Right,
but
which is
that
still
commonality is in 3 screens.
Right.
Yeah,
It's
that's
just
by date in reverse order, right?
Yeah, or whatever. And again, when you get to the code, it may not even be the same code, but logically it's the same. So then you start trying to drive towards, like, for me the big rule is never repeat code. So if I can find a way to save myself 3 or 4 lines of code, I'll get obsessed with it. But again, to me, componentization is about breaking things down, complex things down into its smallest workable unit.
Yeah.
We talk about
that's
the UI.
That's where I was starting before, right? Is that the other approach, the other end of the spectrum is just, as Chris said, code your way out of it, right? And don't break it down, or break it down by, like, pages rather than features or functionality.
Well, I mean, what's the penalty? What's honestly the penalty in cutting and pasting the code that searches everywhere that it's needed?
It's quick, right?
The penalty is later when you have to go fix something, but
maintainability
at the time of creating the application, it's too free. It's too easy. So it sounds like
my
we're
argument
identifying.
Is it's only free because you don't know a better way.
Sure, of course, no, of course.
My way, I guarantee I can write it faster than you because I've written it once and I can plug it in 7 places.
So we're identifying again and again reusability as a key characteristic to know that you've built, not just that you've componentized, because you can build a component, but it's not until you reuse it that you can say, this is a quality component. Like, I've done a good thing here.
I'm going to disagree. And I think you hit on something where a lot of developers make mistakes when they think of interfaces. I don't care if it's going to be reused. Is it some logical small piece of something that I can build independently? That, to me, is the driving force. If it gets reused, that's bonus.
I don't know.
Is it a sign of quality that it's reusable without much friction?
Exactly. I completely agree, Todd, except that I think reusability is the measure of whether or not you have implemented modularity correctly. Whether or not you've created a truly independent component, because if you can pick it from one context and drop it into another context and it still works without modification, then yep, you have, right?
But I'm willing to hear what you're saying, Todd, in that just the fact that it's not reused, like, that's not the measure of its quality.
That's not the reason you do it.
It's that I think, like what Jess and I were kind of saying, is maybe the fact that you could reuse it with low friction is the measure of its quality, not that you are doing it.
Yeah. And I also say that, and again, this gets to the idea of good engineering principles and refactoring. If I have a component, I've written it, now I come into another screen or I get a new requirement that says, hey, you know what, 80% of that's the same? Refactor then. Do that
Mhm.
refactoring then, because then you get the bonus, right? Componentization is not how it always goes. Life's not it's not a destination, it's a journey, right? All these things are a journey. Software should be constantly about evolving software. To me, it's not like great. I have created 5 components that are reusable. That's a bonus, but it should always be look at your code base. This new requirement came in, or now I've been listing 2 different ways, but I know I can do it better. Let's componentize it. Let's now take it and come up with that commonality.
Mhm.
To me, that's the part a lot of developers make the mistake. They and it's not necessarily their fault. It's just to do with usually their time element or bad requirements. This is where they experience it, and having the mentor come in, I think,
Yeah,
helps.
so the component reveals itself to you, is what it sounds like you're saying, and that it's too easy for, a software team to just ignore that. Well, we don't have time. We're constantly adding new features. We got features to add, but so how do you
It's an
know?
investment,
When
right?
does it reveal itself? What are the characteristics that make you stop and say, no, hold on, let me go and care and feed for this code base because I've identified an opportunity to make a component here?
Well, a lot of it depends on the dynamic of the team and process. At least in my opinion. To me, I believe refactoring code any day, and I've done it. Sometimes not isn't the best time to do things, just because I get obsessed with it. Um, there's no right or wrong answer, in my opinion. To me, the way to do it is I always go back to the principles of domain-driven design. Think about the problem not in software. Think about the problem in the real world. Then from that, drive in. What is the user trying to do? Why are they trying to do it? What are the repeatable patterns they're trying to do? And to me, it's just like it's almost natural to do it this way. It wasn't 15, 16 years ago. I had other people who came and tell me, do it this way. It's much easier. And I was always like, well, I don't. This doesn't make sense. Why would I use an interface for everything? And I'm not going to use an interface until I have 2 things that need that interface. And they're like, no, don't think that way. Think about that small piece. And that, obviously, back then was more about classes. Here's a class. We just want to deal with the interface. We don't want to deal with the implementation of it. To me, that same thing with the componentization. We want to deal with, here's a thing. I want to plug it into my application. I don't necessarily care what's behind it. All I
Right.
care about is, does it plug into my
The
application?
contract.
Yes. And does it not introduce a friction, right? I
Yep.
mean, I think about this when I deal with any kind of framework or anything I add. What are the pros and cons to adding this? And ideally, to me, a good component or a good framework, I can plug it in and pull it out without breaking anything, without breaking the rest of the application. That to
Yeah.
me is more important.
Yeah. Well, for me, the answer is it really has to do with complexity.
hmm
So modularity is really about dealing with complexity and breaking a complex or a large problem down into smaller independent chunks that you can solve individually. But when you have an inherently simple problem or simpler problem, you may not need to break it down in order to be able to deal with it effectively. And I think that's what leads to those tutorials that show you creating the DB context in the MVC controller and then calling it right there, is because that's the appropriate response to that level of complexity, right? If I've got a blog and I've got a website that all it does is it goes to the database and it pulls blog posts out of the database and maybe some comments and displays them and renders them as HTML. Why do I need to add any more complexity? Why do I need to add 3 more layers of a repository and blah 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 blah, when all I'm doing is just going and grabbing data and putting it on the UI, rendering it to HTML, right? And so I think the answer to that is, as you go forward and your domain gets more complex, and now you have customers and orders, and these things have relationships, and then the customer has relationships to other customers, and then they've got accounts that you need to deal with, and blah 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 blah, and your domain just kind of increases. Now you start worrying about these things in different domains in different contexts, right? You start worrying about, now you need customer information not just in that one MVC controller, but in 20 different places. And so now what do? Now, do you copy and paste that DB context code and make those calls? No. Now you centralize it into a service or a manager. You centralize that logic into something that can be shared, a component that can be shared across those other things. But it's driven by the complexity, right? You don't necessarily need to do that, nor necessarily should you do that until you have that level of complexity that kind of demands it. So I truly view software as this growing thing, and it's a garden that needs to be tended. And when you have one flower in the garden, there's really not much you need to do. You don't need to plan anything, right? Just water it every day. Just give the server power.
Make sure it gets sun.
Yeah, right. But as it starts growing and growing, and now you have close to us, we have this big ornate garden called Longwood Gardens, right? It's one of these things where you have like these different areas that have different themes and all this stuff. Like now, this is a huge thing that you need literally a map to get around, right? Then, we talked to Matt about code sprawl, right? When your domain gets complex enough that you need to worry about code sprawl, that's when all of these things start coming into play.
Yeah.
Okay, so we're trying to identify when you go ahead and say it's time to move code or work out of being directly used in the view.
Right.
Okay, so we can all agree that maybe that needs to be moved into some kind of module. So in JavaScript, that might be some kind of like modular closure that gives it a little encapsulation. Could be a C++ class. When do you know that it's time to move it into its own project, its own assembly, or its own NPM package? Like now I have to go one level up because what does anything ever drive you to that man, this shouldn't even be part of the. So far we've been picking on ASP.NET MVC and then web spas with Angular or React or something. When do you decide that this is an important enough component that it needs to even come out of this project and be something that we rely on externally?
I try and stay away from the .NET assembly argument as much as possible, but really, that you made a really good parallel there. .NET assembly, which kind of turns into a NuGet package, which is really where the conversation goes to, right? NuGet package, NPM package, whatever. But when you talk at that level, why do you need an NPM package or a NuGet package? It's to consume that component in multiple different projects at the most generic level, project, solution, whatever, multiple different applications that are independent of each other. Right. And so I've got application X over here with one team in one company, and then I've got project Y over here in another team, or maybe even a different company, but they're able to leverage that same implementation, that same component. Then that's a clear, obvious choice, right?
And I mean, these can be internal feeds. I'm not talking about publishing on
the right. Forget about public or private or whatever. Yeah. But even if in one team, I'm really trying to make an exaggerated point here of talking about teams and companies. But even within one team, I have two different applications that are completely different, but their domains overlap a little bit, and so I can reuse that logic that I defined in one application into another application. But when you're in just one application and there's no other applications that you can use this in, when do you chunk it up into projects? I think tends to be pretty arbitrary, and everybody's got their own opinion. And that's why I shy away from those conversations, right? So if my solution is broken down into 20 different projects versus 1 or 3, it's just up to the team to figure that out. It really makes no difference. The small differences it does make is that it takes a lot longer to compile a Visual Studio project or a Visual Studio solution if it's got 20 projects versus 3. But come on, right? I mean, it's really at that point it's just a matter of code.
I mean, those are different issues. But I think you identified something when you said that maybe the fact that it needs to be used across projects. And I want to stress this isn't just an ASP.NET thing. This could very well be just a regular old web project that says, well, we take NPM dependencies, don't we? Or maybe we use Bower, or heck, maybe you just get stuff off of a file share. I mean, who knows, right?
Yeah, that's it.
But you have componentized, you have broken things up. So if you have a team or a person who has developed a component and it's really useful, like maybe it's like an address form component, okay, other teams begin to rely on it in your org. What happens when other teams start to ask for for improvements or features. How do you keep that from getting out of control? This is your component. It's supposed to be reusable and solve a problem. And is it going to start to grow warts and lumps?
Well, at my organization, we ask for money. If you need changes, you gotta give us money. It's as simple as that. We just join in on your project.
So you hit on a couple of things, Chris, I think are important. We talk specific about what you just talked about first or last year. If you are going to get into this concept of having multiple teams work on components, you got to have certain people who kind of oversee all of it all, because what you got to be very careful of is they don't just take your component and start making changes to it.
Mm-hmm.
Yes.
I have the code, I'm going to start making changes to it.
Yeah,
Yes.
Start checking in stuff, right?
Right.
If you have that sort of
right,
have that
They-
requirement, then you got to start thinking about, well, they're going to have certain behaviors, right? Click event get handled, or where the data comes from. There's going to be certain things you're going to want to make sure the components, like I just show data, or I talk to web service X. That's all I do. So if you make the component as small as possible, when they need something else, they need to build another component. But if you don't have that oversight, it's very easy for someone to like, no, we're just going to add a new method here, right?
Well, right, and that's exactly the idea that I was getting at earlier with the orchestration components versus the presentational components. Is when as the more domain specific, or rather the more logic that you put in a component, the more behavior that you put in a component, the less reusable it becomes.
Yeah.
I mean, it's almost a universal rule. It's almost this inverse effect, right? And you've got effectively this spectrum. On one side, you've got reusability, and on the other side, you have like solves a business problem in its entirety. And you can't have both. You can't solve a problem and implement a full-fledged user experience and also have a truly reusable component, right? That full-fledged user experience can be built of reusable components, but in itself, the more specific it is, the more specific a problem it solves or experience that it provides, the less reusable it is, like almost by definition. And so by constructing that thing with, you have the presentation components, and you have these lists, and they don't do anything. When the user clicks on them, they just trigger an event and say, hey, the user clicked, right? They clicked on this row or this customer or whatever, and then it's up to something else to actually do something with that information.
So I've actually run into this in some cases, more within a single application, but also I've done it across several different applications. There are different kind of components, right? There are components that basically are straightforward. We talked about before: login, contact, search. There's also other components, like a form, where it may make sense that the component, what it does is build a form dynamically, right? Or support some kind of templating tied into it. If you have use cases like that, by taking that approach of using templating and metadata and stuff, now the component is more reusable, because all the consumer is doing is providing that metadata, and then the component renders a UI or does whatever. So there are different kind of components and different ways to sort of solve those problems. And you have to be willing to keep moving code forward to do those things. Maybe day one doesn't do that, but then when you start seeing 5 different people kind of using slightly different ways, you try to find that way to make it so it is more reusable.
Yeah.
So I think the other good thing, we kind of circle back to what you're talking about in the beginning. When we talk about components, you talked about the parent and child. That is a classic example of where a lot of people go wrong. They think of component as like a UI thing. So they build we'll use a grid example. They build a grid that does 1,000 things. That may not be right. Maybe it should be more of a grid container, and then you have a row widget or something else, or column widget, whatever would make sense to do the specific things to that subset of data. You got to be careful to really break things down as small as possible.
Yeah.
And if you're not doing that, then you probably aren't taking advantage of this pattern, these type of patterns.
Yeah, you don't have a grid component that deals with every aspect of a grid, including row management and column management and cell management. You have a grid, and a grid has rows, and rows have columns, right? And a grid and a row are a cell, and so each of those things, you got a grid component, a row component, a cell component, whatever.
Yeah.
And you break it up into those small, and maybe even smaller than that, depending on the use case. And so each of them implement their own specific thing. Yeah, I completely agree. All right, so where are we at now? I feel like we need to wrap this up. I don't know. And
Uh,
we haven't talked about the web in the past 30 minutes. So,
so let's take it back to the web. So
well, do we? Because at this point, I'm dead serious. Like we haven't really talked about the web, and the examples we gave in the web were like they were good examples just from a generic sense. They didn't necessarily have anything specific to do with the web. So, do we change the show right now at this point?
Is it hard to be generic when we don't go into the frameworks? Because the web itself, I don't know if it helps us. Like an HTML page doesn't know anything about components. You have to start pulling in. You almost, by definition, have to say, well, when we're using Angular, we build components this way, and when we're using Aurelia, we build them this way, and React builds them
some
this
other
way.
way, yeah.
It's like you almost
So,
have
what
to
is the
start talking
no?
framework.
But what is the lowest common denominator there? Right, the lowest common denominator is the DOM and the JavaScript APIs, the core JavaScript APIs. And so when I say the DOM, there's a pattern of interaction with the DOM that has been there since the very beginning, or close to the very beginning, which is attributes, right? So Todd, when you talk about contracts, inputs, outputs, and we've mentioned events a lot, right? Kind of raising an event that something happened, because that's the browser is very event driven, right? When I click on something, that's an event, and other than that, the browser just sits there waiting for events. It's a big event loop, right? So you have attributes, DOM attributes to pass data in and out,
Mm-hmm.
and then you have events. You know, you can wire up a click event to a DOM attribute, and you can create custom events. And the web component spec takes this even further and provides a whole lot more on top of that. It allows you to create custom elements and provides you with the idea of the shadow DOM, so you can do some other work over here that only the side effects actually get rendered out and affect the page itself. But I think those are the concepts. To directly answer your question, Chris, or the statement that you made earlier, that's the commonality, is that all of these frameworks are built to work on top of the web, specifically on top of the DOM.
Yeah, and I would just add to it, all those frameworks also are pushing the concept of componentization. Because how do we do it now, right? Let's take a step back. Before we had jQuery, what did we do? Put a bunch of global events. We may have grabbed a DOM element to try to do on click, or you may have went right into the markup and said, on click, JavaScript, call this when this gets clicked. And the problem with that is now you're mixing logic and markup. UI and controller code are getting mixed up. So what's the first step? When we had jQuery, now we're at least subscribing to the click events or whatever in JavaScript. That's a first step. But it's still not modularized or componentized. People started saying,
Without web components and the shadow DOM idea, the HTML DOM, it only has global scope. So your JavaScript has to know, like, there's no way around it. It has to tightly know what class or ID to deal with. Where I think one of the ideas of shadow DOM, right, or not, I don't want to call out shadow DOM, but shadow DOM and web components is to say, build a component, and if you use the ID address in that component, but then maybe somewhere else on the very same HTML page, you're representing IP addresses, and you call something else an address, they don't conflict. They're in their own components.
yeah, I mean, that's more about the way it's to try to isolate stuff. To me, again, what I was trying to explain is you don't need web components to do componentization, right?
Right.
You don't need these frameworks. The frameworks just make it a whole lot easier, and they're like guidance, right? They force you to start thinking down this path, because I've done this without frameworks. It's very hard, right? And usually you can get a good foundation, you can get going. Then more developers come in, and because they don't have a framework that sort of guides them to the right way,
Yeah, right.
they just start adding global events.
Start adding stuff.
Well, so using the DOM API isn't necessarily intuitive. I wouldn't really necessarily call it hard, but it is definitely very verbose and unintuitive. So while it is true, Chris, that you are dealing with a global namespace in both HTML and JavaScript, it doesn't have to be the case, right? So if you treat your kind of level, your component or your level of modularity as the DOM element that you're dealing with, and you scope all of your behavior to that, you don't need a framework. You don't even need jQuery to do that.
Yeah, right.
jQuery plugins were a great example of how to do that, because the contract of a jQuery plugin is here's the element that was selected. That's where it all started. And then you weren't supposed to really go and do global stuff, although everybody did. I mean, that's basically an anti-pattern, but you get that element, and everything you do is based off of that element. And so the context of that element. And then you can create children, and then the whole pattern, when I say everything is a component, that whole pattern just continues on down, right? Now those children become their own components, and they can have children, and so on. And so when you put these rules in place, like you don't break that component boundary, you don't go outside of your own boundary, outside of your own DOM element. Very specifically, the DOM element is your boundary. You don't go outside of that boundary. You don't go down 2 levels into your children's children. Right? You're not directly manipulating anything inside of your children. You're just interacting with it through standard DOM stuff like manipulating IDs or something. Then the DOM is your interface.
I think what you both hit on is the reason why we need componentization in the web, and also why it's taken so long for us to start adopting these things.
Yeah.
The DOM has made it easy, right? I can select anything in the DOM element that has an ID.
Yes.
Right? Whether it be with CSS, whether it be with jQuery, with pure JavaScript, it's really easy. Nothing prevents me.
Right.
Where in some other UI frameworks, generally speaking, yeah, in Windows you could have grabbed any HWin, but it was kind of hard, right? It was hard to go find it. There were the layers to go do something wrong was much harder. Where the DOM is just like, hey, give me the body tag and start walking down the tree.
Yeah.
Nothing.
Well, you're right. It practically encourages you.
Or
to
you
do
could
that.
do like a CSS query selection, basically, built right into the JavaScript API now.
Yeah.
Yeah.
You
But
know?
all of those APIs that you're using, everything that we're talking about, get element by ID, get element by class name, get element by tag name, and everything, all of those APIs are on the document. The document is just an HTML node. So any node that you get will have those selectors on it as well. And
Right.
that's what I'm talking about. Even at the API level, that's what I'm talking about, right? When you start everything at, here is the element, and you scope everything to that, now instead of saying document.getElements by ID or by class or whatever, then you start saying element.get by class name, get by tag name.
Yeah.
And that is how you kind of can enforce that.
Well, now once you have the element, you pull it into the JavaScript that acts on it, and then you don't. That's it. You've wired it up.
Yes. Right.
Yeah.
Right.
So then you continue to have that modularity and that separation even of the DOM and the behavior that you're implementing. In other words, JavaScript.
There's really multiple layers of JavaScript that you need. You need this sort of middle layer that wires into the markup, but that's not the service layer. It then now it's kind of like an ASP.NET MVC controller where, oh, I've been fired, an event has been fired on me, so now I know that what I need to do is go grab a little bit of data, maybe the credit card number you put in, and pass that off to the billing service that's going to go act.
Well, then there's different levels or different amounts of framework and plumbing that you can use in order to make your problem easier. So going back to the idea of complexity, right? It's all driven by complexity. If you've got a simple thing, why not just wire it up directly, right? Just create one HTML file, one JavaScript file, and go nuts. You don't have to break the rules. You can still have all of your logic in the JavaScript and all of your view in the HTML file. You still got that separation of concerns. Just like if you have an ASP.NET MVC application and you make a database call from the controller. If you've got a simple application, that's fine. Once you've got a more complex application, then you need to break it up more. You can apply those same approaches even in development, right? So Chris, you just mentioned the controller. You don't need to implement an MVC approach in a basic application. The MVC approach will help you, it will encourage you to maintain a better separation of concerns as your application gets more complex. So if you know going into it that your application is going to grow to be complex, then choose a framework that helps you really drive that separation of concerns, and then choose an approach that just says, okay, no matter what the component is, no matter what the level of complexity within each individual component, we're doing things this way for everything just because we know the application as a whole is going to be very complex, right? So in other words, we're picking Angular. Angular encourages model view controller because we know that the application is going to be complex. And so in a lot of places, we're going to want to separate that model view controller. And in the places where we don't really need to because they're not complex, we're still going to do it anyway, just to be consistent. And it's still clean. But in those cases, yeah, it's arguably overkill.
Yeah.
Right?
Today, it may require much change. It may not be overkill later.
Exactly. It's setting up.
I want to
exactly. The application is going to grow, right?
take a step back. We talked a lot about today about the idea of contracts. To me, when I think about patterns, particularly like the MVC pattern, it's a contract. I'm basically saying is something's going to be a view, it has its set of rules. Something's going to be a controller, it has its set of rules, and then something else is going to be the model. To me, that's the idea. That's componentization to me. Using the MVC pattern is a level of componentization because you're saying there are three pieces that are going to orchestrate together to solve this problem, as opposed to one just jamming everything in one place.
That's not really a contract, though. What I'm trying to talk about
it's
is
not a physical contract, but it's the pattern's encouraging you to follow a certain set of rules. That's what I mean by contract.
That's a pattern. I would say the contract is how different components interact with each other, and then how they implement internally is completely irrelevant. One could be implemented using React, and the other one could be implemented using jQuery. If they follow the same contract, or if they expose a certain contract, then it doesn't matter how they interact with each other, or it doesn't matter how they're implemented. You interact with them through their contract, right? By setting.
I think we might be talking about different things. So, I do agree with you, yes. In those cases, yes. Yes, the contract would be the commonality.
Right. So what are you saying the model view and controller are a contract?
I guess what I'm trying to get to is the idea that the model controller is a pattern, right? And then you have frameworks like Angular that implement that pattern.
Mm-hmm.
By just going down the path of saying, I don't want to have IDs in all my DOM elements. I want to have my DOM elements over here, and I want to have one place where I grab the events, and then another, and then it calls off to something else. That is sort of to me the first step to getting to components. And then I can say, well, maybe there's a comment. I can build a UI component or a service component. By just making that first step, you've already, to me, increased your maintainability of your code.
Yeah.
Because to me, that's the holy grail, right?
Yeah.
Code needs to be maintainable. It's 2016. Yeah. We cannot develop applications like we did in the 1970s, 80s, and 90s anymore.
Or 2000s or 2010,
well,
2014.
I'm
last
saying
week.
As an industry, it's time to mature ourselves. These things are a way to make mature. The web needs to become more mature. We've had all these patterns and things in other frameworks for a while. Now these things are getting adopted. A lot of it's to do with the fact that because we're trying to build more complex web applications. We're not building the simple world web application.
The complexity is increasing, so we need to maintain it. It hasn't been as important to maintain it because the complexity hasn't been there.
Yeah, we're moving things for content. If you're building a content site, you need a whole set of different patterns and frame components and do things.
Right.
So, context matters.
Yeah. Okay.
I think that's a show.
Is that a show? All right. Yeah. Chris, you got anything else?
No.
All right.
Components.
Yeah. Components. Woo!
Millions and millions and millions of components.
All right. And on that note, it sounds like a show. So you, listener, what do you think? What's your favorite way to break your applications up into components? Have you used any of the approaches that we've discussed here, or do you have any more of your own? We'd love to know. Please leave a comment on the website, staticvoidpodcast.com, or send an email to comments@staticvoidpodcast.com. And side note, if you've tried to email us and it bounced back recently, that's all fixed now. So, sorry.
We didn't have the right component to do that work.
Yeah, you had to fix the email component.
It wasn't componentized properly. So, sorry, but feel free to try again. It's fixed now.
Thanks for the emails, though. There's some really great definitely. Comments.
And as always, if you have a topic you'd like us to discuss on the show, please feel free to let us know through those same channels. We want to make sure we're talking about the things that you want to hear about. Todd, Chris, thanks for the chat.
Yep. See you all next time.
Thank you, listener, for spending the time with us. We hope that you enjoyed it, and we look forward to seeing you next time on the Static Void Podcast. Done. How do I stop this recording? There we go.
Extract audio. Flack,
All
right?
right.
You want flack?
So, what are we going to do with that? Yeah.
You don't think that was good?
I thought that we had a lot of tangents.
Well, that's
You
the.
thought it was good?
I think
Well,
we have to
I think
accept the
sometimes
fact.
that happens. The more I listen to other podcasts, the more I've noticed that I'm more critical of like noticing that, boy, they really didn't talk a whole lot about the show topic, or
Yeah, right.
it went on for 25 minutes, and I guess it's just part of it, right?
I
It's just
guess
part of it.
so. I guess.
I think we're fine if we now take it in other future ones. We focus on certain things,
Sure.
like a framework or other patterns or things like that.
Well, and when I said that in the middle, when I was like, so we haven't spent much time talking about web, I totally meant that to be like a production note and like an
Yeah, no, I
internal
figured that was
conversation.
you were going to cut that out.
No, but then as we started talking, I'm like, well, that was awesome. Like I just like pointed out to the listeners, like, yeah, no, we're recognizing that we haven't talked about web, so yeah, let's get back to it. I think that was
Yeah, it wasn't that bad.
actually it ended up being a pretty good segue.
So here's the question. So you and I, Jess, we know Angular, right? Well enough
Yeah,
to talk on it.
yeah.
But do we almost need to have sort of a why Angular show? Like,
Yes,
why do.
that was kind of it. Yeah. I mean, that wasn't it, but that these, I think, why Angular. The answers are going to be the things that we talked about in this show.
But no, why Angular over React over something else? Like, what. For me, it comes down to MVC and dependency injection. It just works. It's there. It seems like a natural fit.
I don't know. I'm hesitant to do the cage matches,
Hmm.
the verses, but definitely I'm willing to talk about frameworks independently, especially Angular, because
Yeah.
I would hate to come across as like, well, here's the framework we know, so let's talk about how awesome it is because we chose it, right? I
But
mean,
we.
talking about why we chose it is a valid conversation, but I'm worried about it coming across like we made a really good decision. Let's congratulate the great
Yes.
decision that we made.
The problem is, I think pretty much through any show we've talked about patterns, anything to do with UI, Angular almost always comes up. It gets mentioned a lot because that's what we use. That's what we know.
Right. That's the show right there.
Well, on the other hand, I think that people know it too, so you're giving them a common frame of reference.
It's popular.
'Cause,
Yeah.
look, I'm not an Angular expert, but I know that certainly other people are going to understand what I'm talking about.
Yeah.
Yeah.
I think
Yeah.
we picked Ember or Aurelio, more of the fringe ones, and like we're going to just talk about that. Then I think it's a little more opinionated and less about patterns. I don't know.
Yeah.
I get that's feedback. That's what we need feedback, right?
Yeah.
See what people say.
Yep. Yeah. Agreed. Okay. Cool. I think
So
we
what
can
is
turn
next?
off the broadcast now.
So what is next?
Thanks everybody for joining.
Yes.
See ya.
Next